Welcome, my friends! Here is the graph of a parabola. We say that this parabola is upward opening as, well, the direction it opens is upward, into the positive values for y. Notice that this parabola has symmetry about the line x equals 2. Everything to the left or the right of x equals 2 is like a mirror image, and the graph is symmetric about x equals 2. For this reason, we state that the axis of symmetry for this parabola has the equation x equals 2. The minimum value of the function, which falls on the axis of symmetry, is what we call the vertex. The vertex in this case is the point 2, 1. The vertex in an upward opening parabola like this one is the minimum point on the graph, and as we'll see momentarily, the vertex in a downward opening parabola is the maximum. This parabola has no x-intercepts, as it does not cross the x-axis. However, the parabola does cross the y-axis at y is equal to 5, so the y-intercept is y equals 5. Here's what we call the standard form equation of a parabola or a quadratic. Y equals ax squared plus bx plus c. If a is positive, we have an upward opening parabola, and the vertex will be the minimum value of the parabola. This is like the parabola we looked at on the previous slide. If a is negative, then we have a downward opening parabola, and the vertex will be the maximum value of the parabola. This will be a parabola that looks like this, with the vertex at the highest point on the parabola. The equation of the axis of symmetry can always be found by x equals negative b over 2a. Recall that this is the vertical line that splits the parabola down the middle. In order to find the vertex, we must plug in the axis of symmetry value into the function, which will result in the point negative b over 2a, y, which will be the maximum in a downward opening parabola or the minimum for an upward opening parabola. Let's take a look at an example. Suppose we are given the parabola y equals negative 2x squared minus 8x minus 7. We know this is a parabola based on the x squared term. The coefficient on x squared is negative, indicating that this is a downward opening parabola. Know that you can always find the equation of the axis of symmetry through the formula x equals negative b over 2a, where a is the coefficient on x squared and b is the coefficient on x. In this case, b equals negative 8 and a equals negative 2. Therefore, negative b over 2a is negative 8 divided by 2 times negative 2, which is 8 over negative 4, or just negative 2. That means the equation for the axis of symmetry that cuts the parabola in half will be x is equal to negative 2. Also remember that the vertex of the parabola occurs at the axis of symmetry. So if we want to find the vertex, all we have to do is plug in x equals negative 2 into the function. Negative 2 times negative 2 squared minus 8 times negative 2 minus 7 simplifies to negative 2 times 4 plus 16 minus 7, or negative 8 plus 9, which is equal to positive 1. This is the y-coordinate of the vertex. We already found that the x-coordinate is the axis of symmetry of negative 2, so that means that the vertex of this parabola is at the point negative 2, 1. We could also find the range of this function, as the range is just the possible values for y. Since the maximum point on the parabola is negative 2, 1, that means the range, the y values, must include anything equal to 1 or smaller. So we would say that the range of this function is y is less than or equal to 1. Here is the graph of this parabola. You can see that the axis of symmetry is at x is equal to negative 2, just like we found. You can also see that the vertex is at negative 2, 1, which is the maximum value on the parabola. We can also see that the range is y is less than or equal to 1, as the highest value on this function is y equals 1. Consider the equation negative x squared plus 4x plus 5, which is a parabola. Let's say we want to find the x-intercepts and the vertex. The easiest way to find the x-intercepts is to set y equal to 0, as we know the x-intercepts occur when y is equal to 0, as y equals 0 is the x-axis. the best way to solve an equation like this one is to factor. First, I'm going to pull out a negative 1 so that we have negative x squared minus 4x minus 5. Now we need to find two numbers that add to negative 4 and multiply to negative 5. Can you think about what two numbers will work? Negative 5 and positive 1 should do it, as negative 5 plus 1 is equal to negative 4, and negative 5 times 1 is equal to negative 5. We have 0 is equal to negative x minus 5 times x plus 1. We can divide out the negative 1 so that we don't need to worry about the negative sign anymore. We have 0 is equal to x minus 5 times x plus 1. Based on the zero product property, the only way the product of two numbers can equal 0 is if at least one of those two numbers is equal to 0. So that means we have x minus 5 is equal to 0, or x plus 1 is equal to 0. If x minus 5 is equal to 0, that means x is equal to 5. And if x plus 1 is equal to 0, that means x is equal to negative 1. That means our x-intercepts are x equals 5 and x is equal to negative 1. Now let's find the vertex, which will be at the point of the axis of symmetry, negative b over 2a. We have negative 4 divided by 2 times negative 1, which is the same thing as negative 4 over negative 2, or just positive 2. That means the x-coordinate of our vertex is positive 2. If we plug 2 back into our original equation, we can find the y-coordinates. Negative 2 squared plus 4 times 2 plus 5 is equal to negative 4 plus 8 plus 5, which is equal to 9. That means that our vertex is at the point 2, 9. Okay, let's try one more problem, this time a word problem. Ellison Enterprises makes pinball machines. The cost in dollars to manufacture a pinball machine, C, depends on the number of machines made. If X machines are made, the cost per machine is given by the function C equals 1.1 x squared minus 440x plus 49,000. How many pinball machines must be made to minimize the unit cost? Essentially, this question is asking where the parabola is minimized, since the unit cost is represented by a parabola. I'm not 100% sure how realistic it is to have a quadratic equation model the unit cost of a pinball machine, but we'll run with it anyways. We know that this equation is an upward opening parabola as the coefficient on x squared is positive. That means the vertex will be at the minimum. The vertex of a parabola will occur at the axis of symmetry, which has the equation negative b over 2a. In this case, we have negative 440 divided by 2 times 1.1, which is the same thing as 440 divided by 2.2. If you type this into your calculator, you will get x is equal to 200. That means that 200 pinball machines must be manufactured to minimize the cost per machine. We could also find out what that minimum cost is by plugging 200 back into our equation. We have 1.1 times 200 squared minus 440 times 200 plus 49,000. If you were to plug that into your calculator, you would get 5,000. Therefore, the cost per pinball machine can be minimized to $5,000 if 200 pinball machines are made. Alright my friends, that finishes up our video relating to the vertex, axis of symmetry, and zeros of a parabola.